Hello guys, this is Saeed Mohammad Wakas. The topic which I am going to discuss today is related to the air distribution system design, that is grill sizing and selection. If you have seen my previous video regarding air distribution system design, in which I have explained about the air diffuser sizing and selection. So in this video I'm going to talk about the grill sizing and selection. So as you can see here, I have a spreadsheet over here which I'm gonna use for this purpose, and these are the tables for flat ceiling all outlets which I'm gonna use, and this is for the beam ceiling. So let's start. So let's say we have a space. This is the space and this is the small store in here. As you can see, the dimension of the store, length is 32 feet and width is 23 feet as mentioned in here, and the height of the store is ceiling height is 16 feet. So the next thing we have to check here is the load equally distributed. So the load in this store is equally distributed. What does it mean, equally distributed? Equally distributed means there is no source of heat coming from the outside, or there is no extra source of heat inside the room, because sometimes you have a door that is frequently open. So in that case you have some outside air entering inside the room, and load will not equally distribute, or you have some equipment inside the extra equipment inside the store. So in that case you have load that is not equally distributed, but in our case we have a load that is equally distributed. Now the ceiling type which we set over here, the ceiling is the flat ceiling, because we have two types of table. One is for the flat ceiling and other is for the beamed ceiling. So we have ceiling, flat ceiling, and the air quantity, dehumidified air quantity, which we have calculated for this store. So you know that how to calculate the dehumidified air quantity. I have explained in my previous videos like you can use HAP software or E20 spreadsheet to calculate the dehumidified air quantity. So the dehumidified air quantity which we calculated for this space is 2000 CFM. Now the next thing is the temperature difference. We have to calculate the temperature difference which is necessary for the grill sizing. So temperature difference, how we will calculate, that is room temperature minus supply air temperature. Room temperature which we maintain inside the store is 75 and the supply air from the machine is 55. So if we get the difference, temperature difference will be 75 minus 25, that is 20 degrees Fahrenheit. So next important thing is recommended velocity. How much is the recommended velocity for this space? Because each application has their own recommended velocities. So you can see table 20, recommended outlet velocities, you can see it here for the residence apartments, church, hotel bedroom. So in our case we have a store. We said that store is the application which we have used in here. So for the store upper floor, the recommended velocity is 1500 fpm. So we have used recommended velocity 1500 fpm based on table 20. So now important thing is we have to calculate the number of grills, how many grills required to place in this store, and what will be the size of each grill and each grill air quantity. So this is what we have to calculate. So before, and this is the interpolation tables I'm gonna use as well. So before proceeding towards the grill sizing, I want to talk about the channel membership. If you guys can join the channel membership, you can get access to different perks. So all you need to do is just click this join button. So there are different levels you can see here: MEP Excel sheets, softwares, career book, plumbing design books, and complete MEP material. So you can select whatever material you need. So let's say if you select this MEP drawings career book, there are 3 perks given in this one. You can click this about more perks and you can see the details, what material you will get in this perk. So if you want to see the details of the spreadsheets and everything, so you can see in here. So there are total 25 spreadsheets, as you can see in here, which are available, And list of the softwares, you can just send an email on this email address mentioned below, sayyidmuhammadw@gmail.com. So even after taking the membership, you can send an email on this address to get access to the required material. So let's move back to our spreadsheet. So there are two important things that needs to be calculated for grill sizing and selection. That is minimum blow and the K factor. So first we will calculate the minimum blow. So how do we get the minimum blow? So basic rule for the minimum blow is 75% of the room width is your minimum blow. So in our, for this equally distributed load condition, so you must have equally distributed load condition, then you can use this rule, that is 3 by 4, that's 75% of the room width. If you have not equally distributed load, then you can take the maximum blow, that is equal to room width, 1 times of the room width. So in our case, the heat load is equally distributed, so we have to take 75% of the room width as a minimum blow. So you can see the width is 23. So 23% if 75% of 23 will be 17.3 feet. So minimum blow in our case is 17.3 feet. Now the second thing we have to calculate here is the K factor, that is air movement factor. How do you get the air movement factor? By using this formula, dehumidified air quantity divided by air outlet opposite wall area. So dehumidified air quantity, we know that that is 2000 CFM, and the air outlet wall opposite area. So we are going to place the outlets on this wall 32 feet and the height is 16 feet. So opposite wall area is also the same, 32 feet is the length and height is 16 feet. So if you put the values in here, you can get the K movement factor, that is 3.91 CFM per square feet. So now you know the minimum blow and the K factor values. Now you can easily check the grill size and how many grills needed and what is the CFM for each grill. So let's go to the table and select the grill. So before do the grill selection on this table, I just want to know you how to read this table. So on the top you can see the velocities, then this is for the flat ceiling, 250, 375, 500 and 750 fpm. And here you can see the grill sizes. You can see 30 by 4, 8 by 6, 16 by 6, 24 by 6, 30 by 6. These are grill sizes. And this is the air quantity column, you can see in CFM. And this is the blow column, which we already calculated. And this is the temperature difference, which I mentioned earlier. That is room temperature minus supply air temperature. And this is the minimum ceiling height, you can see here. So all these are same. And on the bottom of the table you can see the K factor. This is the range of the K factor, that is 8.7 to 29, 5.7 to 19. Similarly in this table you can see that this is the range, that is 1.4 is the minimum and the maximum blow is 4.8. Minimum blow is 2.2, maximum is 7.2. So how much is the blow we have calculated? That is 17.3 feet is the blow which we have calculated, and the K movement factor is 3.91. So let's check the K movement factor first and then the blow. K movement factor is 3.91. 3.91 is falling in which range? So you can see that 3.91 is falling in this range, minimum and the maximum blow, that is 2.9 and 9.6. So 3.91 is falling in this range. So you can see here, and the blow, if you check here, this is the blow column. Blow, if you check here, is 17, 34, 33. So we will select the blow now. This is 17, this is 17, and this is 18. So let's say if we check the blow is 17 here and calculated blow is 17.3. So 17 below here, and if you see the grill size is 24 by 6 inches, and the CFM is 486 CFM. 486 CFM. So since this is not the exact blow and the CFM, so what we do, we will use the interpolation formula. So 17th blow here, and if you move to the right side and you see 24 by 6 inches grill with 648 CFM having a blow of minimum, may blow is 24 in here, you can see 24, and at 486 blow is 17. So our blow is 17.3. so just let interpolate the table and get the exact value of the CFM. So blow is 17 and the calculated blow is 17.3, and if you see here at 648 CFM blow is 24. Now we have to check the flow. How much is the flow at 17.3 blow? So 17 feet blow, how much is the flow? At 17 feet, how much is the flow? 486 CFM. 486 CFM. So this we need to calculate. And at 24, how much is the flow? At 24 blow, how much is the CFM? 648 for the same grill size. 648. So how much is the flow calculated at 17 point? How much is the flow calculated at 17.3 feet blow? That is 493 CFM. So this is the minimum blow which we use in here. That means we can select blow not less than 17.3 feet. So our total flow is 2000 CFM, right? So 2000 CFM divided by 493, sorry, 2000 divided by 493. So that means 4 grills we need to place. Even if we change this to 17.5, let's change it to 17.5, and the flow is 498, that is almost 500 CFM. So 500 CFM cross 4 grills, that means we need to place 4 grills, each with a CFM of 500. So 4 grills we need to place. Size of each grill, what we said here, size of each grill will be 24 by 6 inches. This is the size of the grill we selected, 24 inches by 6 inches. And the CFM of each grill, since we said 4, so 2000 divided by 4 equal to 500 CFM each grill. So next thing is we have to verify the velocities as well, that it should be less than 1500 FPM. Obviously it is less than 1500 FPM. If you see, the here is 750 FPM and the interpolation on this side is 1000 FPM. Let's check the exact velocity. So at this point we have 750 FPM, here we have 1000 FPM. 750 and here we have 1000, and the flow which we said that 486, and the other one is 648, this one, and the flow which we calculated here at this blow, is 500 CFM. So 500 CFM, how much is the velocity? So you can see the velocity of 752 FPM calculated here is less than our recommended velocity 1500 FPM. That means our selection is fine. Now the last thing which we have to check before proceeding towards the final selection of this grill is to check the ceiling height as well. So we know the below is 17 and calculated is 17.3 or 17.5, it's okay, and the other one is 24. Now we need to check the minimum ceiling height should be less than this height, then our selection will be okay to check all these items. So at 17 feet, what is the minimum ceiling height? 17 feet below. So you know that this is the minimum ceiling height, and minimum ceiling height we need to check at temperature difference of 20 degrees Fahrenheit, as I already mentioned in the beginning. Supply temperature, room temperature minus supply temperature, it is 20 degrees Fahrenheit. So we need to check this column. So 486 CFM with 17 feet below, what is the minimum ceiling height? That is 8.5 at 486 CFM. 8.5. We need to check the minimum ceiling height at 17.5 feet below. Now what is the minimum ceiling height at 24 feet below? So you can see in here again 20 feet 20 degree Fahrenheit we need to follow temperature difference and check the ceiling height. At 24 by 6 grill size 648 CFM and 24 feet below, minimum ceiling height is 9.5 feet. You can see here 9.5. So by putting these values you get the exact minimum ceiling height required at 17.5 feet below. So this ceiling height of 8.57 is far less than 16 feet. So everything which we calculated here is in the range. So the selection of the grill, number of grills 4, and each size is 24 inches by 6 inches is satisfactory. So we can use 4 grills, each size 24 inches by 6 inches, having air quantity or CFM is 500 CFM. So this is how you can do the grill sizing, air distribution system sizing and selection. I hope you guys learned something from this video. For more videos, keep watching my channel. Don't forget to subscribe and don't forget to press the bell icon. Thank you.